Hello, Physics 20. We are going to be looking today further into our exploration of curved mirrors. You've gone over how to draw diagrams involving converging mirrors. When we meet again, I'll show you how to draw the ones with diverging, which is when you're looking at the back of a spoon. Today we're going to focus again on converging, and what we're going to look at is how do we find image position and characteristics without necessarily having to draw it out. And so there are some rules we're going to look at. If you haven't yet, please find this page in your notes. You can see there are two formulas down there, and I've got a reminder for you to add those to your pink page that has the chart with the characteristics on it, just so that you have these formulas on your quizzes and tests and so forth. So to illustrate these rules that I have written down here, we're going to go right into a problem. A candle is located a certain distance from a converging mirror. So my candle is going to be an arrow. And there is a radius of curvature of 10. So when I have my mirror there, I'm going to make it right about there. And radius of curvature is 10. So this is my center of curvature then, with this distance from the vertex to the center being 10 centimeters. That means my focus is going to be there at 5 centimeters. So right away, even before we start, we can look, at our pink page and say, well, if an object's outside C, where's the image supposed to be? And we could draw our light rays parallel to the principal axis and then through the focus. And I'm going to draw the one through C. And we can see that our image is supposed to be right here. So before I calculate anything, there are a few values that we're going to talk about. And one of the rules in the previous page says all distances are measured from the vertex. So our original object distance, which is DO, which was 30 centimeters, is the distance from the vertex to there. And we also see that our image distance, which would be from that arrow to the vertex, we don't know what that is yet, but we know it's between 5 and 10 for sure, because the focus is at 5 and the center is at 10. There's another rule that's going to apply here that says that virtual images has negative distance, so it's a virtual image. We'll see if that's the case or not. And if it's a inverted situation, which we have here, that means the height has to be negative. So we can see here that it's upside down. It's going to have a negative height. So let's use the formulas to verify that. And in order for us to do that, I would recommend that you write down the formula. And I'm going to expect you to do that on all questions that you use any formula, just like we have so far this year. So this is the thin mirror equation. It's also going to be the curved or thin lens equation when we talk about it later on in this semester. And we're going to plug the numbers in that we know. We know the object distance, that's this blue value right there, we'll go there. We also know our focal length is 5 because it's half the radius of curvature. So when I plug those numbers in, 1 over di equals 1 over, not equals, plus 1 over 30 centimeters equals 1 over 5 centimeters. The question is, what's the value of di? How do we get di by itself? So the first thing we would do is subtract 1 over 30 from both sides. Now at this point you have two options. One, which I think is probably the simplest, is get a common denominator and get the answer. So I'm going to times this by 6, and we get 1 over di equals 6 over 30, take away 1 over 30 is 5 over 30. And then how do you solve that? Well, there's a number of different ways. Again, I think the easiest way is just to flip over both sides. You get di over 1, which is di, equals 30 over 5. And we know that 30 divided by 5 is 6 centimeters. Yes? Yes, that's the case. So that means this red distance that we talked about over here, the distance from the vertex to our image, that's 6 centimeters. That's a positive value. That makes this a real image. Anytime you get a virtual image, you would have a negative distance, which is kind of the opposite of what I said a few minutes ago. Real images have a positive distance. As I've kind of mentioned to you before, later on this week, we are going to take actual objects out. We're going to have a candle burning and the mirrors, and we are going to be able to measure this. And this is where you would be able to see the image of that candle right on a screen because it's real. So that's the answer to part A. Where will the image be? It'll be 6 centimeters from the mirror. Question B says, well, what if the candle's 4 centimeters tall? How tall will that be? And if you look at our diagram, it's going to be much smaller because of the black, the image, pardon me, the object is significantly larger than your image. How are we going to do that? Well, the magnification formula will then be used. And the magnification formula says this, very similar to a pinhole camera, that the ratio of the height of the image to the height of the object is equal to, now the only thing that's different is this minus sign, minus di over do, instead of just di over do like we had with the pinhole camera. Double check that on your pink page, if you wrote it on there, that you have that minus sign there. So if I want to find the height of the image, I can kind of ignore the m part here and just have this relationship or this ratio that the height of the image is to the height of the object as the negative distance image, which we said is 6, to the object distance, which is 30. Now again, how you solve this is many different, well, 2 different ways probably. Some of you are cross multipliers. I try to avoid that and just think of it in terms of opposite operations. The 4's will cancel it out. And so you would go 6 times 4, which is 24 over 30. And some of you would take your calculators and do that. If I just reduce that in my head, 24 over 30 divides by 6. That would be 4 over 5. So that's negative 0.8 centimeters. That's how high that image would be. Now, what are the characteristics of the image, and what are the values that we got tell us about the characteristics? Well, the first one we've already talked about already. If it's a positive image distance, our rules say that that means the image is real. If the height of the image is smaller than the height of the object, we have a diminished situation, definitely smaller. If the height of the image is negative, that means it's going to be inverted. And then our position, we would have to relate it back to this 6 centimeters. 6 is between 5 and 10, 5 being the focal length, and 10 being the center of curvature. So we know that it would be between C and F. And you could have also done what we did earlier and just looked at this, and that would get you the same answer. Hopefully the goal is you won't be drawing them out every time, but it's okay if you do. I think it helps you get a good picture. Now, you won't know how to do questions with the diverging mirrors yet. You won't know how to draw them. You don't know what to expect, I don't think, unless you spend a bunch of time staring at the back of a spoon this weekend. Maybe some of you did. Who knows? So we're going to leave, pardon me, any questions that have to do with a diverging mirror. Just leave them for next time, and we'll deal with them as needed. And one question that I should address here is on this question number 3. What if you're asked about magnification? What if you're asked to find the magnification of a situation? So why don't we just use the example that we just had with the converging mirror. If I want to find the magnification, there's 2 options. You can go height of image over height of object, or you can go negative distance of image over distance of object. You'll get the same answer either way. So here we had a 0.8 to the height of the object was, I believe, 4 centimeters. Just want to double check. Yeah, 4 centimeters. So you would type that in and you would get your answer. So that one, 4 goes into 8 2 times. That's going to be negative 0.2. Same thing with your di over do. The image distance was negative 6. Your object distance was 30. Guess what 6 divided by 30 is? Negative 0.2. No change. Just a reminder with magnification, just like with the pinhole camera, there is no unit. The value is less than 1. That means that it's a diminished situation, or it's been shrunken. It has been a reduction. And the minus simply refers to the orientation, that it's going to be inverted, not upright. So when you see magnification in your assignment, don't be surprised. So you're going to be working in your pink pages, and you're going to kind of start at the front and just keep on going and see how far you can get today. And some of you will get further than others. Just a reminder for you that your behavior expectations are, as always, you are going to be focused on the task at hand and doing your best. Those of you that weren't here last time and didn't get to see your test or your page that you gave to me regarding your focus and your responsibility and that sort of thing, I'll talk to you next time. I've said it once, sometimes you don't hear me the first time. If the question has to do with a diverging mirror, skip it and go to the next one. And you've got lots of questions there to get through. And next time we come together, we'll look at that. So that's it, and I will talk to you next class.